And welcome back. I'm sorry I've been gone for a little while, guys. Got off my game a little bit. Here I am, ready to rock it out, get these videos punching up again, so we can spend more time in class doing what really counts, which is the work. All right. So what we're going to get done today is we're going to take our polar coordinates that we've been working with for a little bit and our polar equations, and we're going to be able to flip-flop them back between rectangular form. Okay. We know a lot of this already from dealing with vectors, but it's a quick little review. Okay. So without further ado, let's get going. Boom. So as a quick concept right here, if I want to take any polar graph or polar axis, here's my polar axis, and I want to go ahead and find out, hey, here's my point, r comma theta. Oh, how can I change this into an x comma y? Well, we already know this from vectors. If I wanted to find my vector, if I knew what the magnitude of my vector and the direction was, here it is. I can find my vector that way. It's also the same way as finding your polar coordinate, because your r is really like your magnitude and your theta is your angle. So it's all the same. So if you just do r cosine theta comma r sine theta, bada bing, you've got it good, good to go. So let's go and take a look at some examples that are pretty straightforward. All right, so it says here, find the rectangular coordinates for D. All right, so it's 2 comma pi over 3. So again, what you should be able to do without a calculator, you should be able to say, well, hey, D is also going to be 2, okay, that's my r, right? This is r, this is theta. 2 cosine of 2 pi over 3, no, not 2 pi, excuse me, pi over 3, comma 2 sine of pi over 3. And I go ahead, and that's the part you can do without a calculator. Once you put it in your calculator, it will give me 1 comma 1.732. And there's my answer. That's about as straightforward as it gets. Okay? So now what I want you guys to do is I want you guys to go ahead and set up the next one. So I come over here. Here's this one. Find the rectangular coordinates for this one. Again, it's okay for it to be in degree mode. I want you guys to set it up and see if you get the same answer that I do. Ready, set, and bada bing. There I am. There's my answer. Now again, if you punch it in your calculator, this one actually kind of comes out kind of happy as -5 comma -5. Okay. What's next? Again, I want you guys to take this one here and give me the answers that you should be able to get, okay, without a calculator. Ready, set, pause me. And drum roll, please. That should be your answer. And if you would go ahead and put it in your happy calculator, you would get a -2 comma 3.464. When going from polar coordinates to rectangle coordinates is all pretty straightforward. It's pretty much your calculator. You got to set it up. Make sure you know what you're doing. Okay, 4 cosine, 4 sine. Get it together. Okay, so now what if I want to go in the other direction? All right, well, let's take that on too. Well, if I want to go in the other direction, again, it's the same thing as if I was given the vector in vector form and I wanted to find out its magnitude and direction. Well, in order to find out the magnitude, look right here. Remember this? That's for finding magnitude. It's the same thing as finding my radius. Now I want to find the direction. Look, same thing. Now here it even gives us some more guidance as far as what to do. When x is positive, you do this one. This down here, depending if it's in radians or degrees, this is what you do when x is negative. Okay, let's just keep that in mind. So your theta is going to be a little bit different depending on what it is going to be x. And again, remember we had that when we had to talk, when we were doing with vectors, right? We had to think about which quadrant we're in. Same thing. So let's go and see what this has got for us. So this first one here says find 2 pairs of polar coordinates for this point. Okay, 2, -4. So again, I go through the same business. It's going to be r, right? I want to find that magnitude of r. or in this case just the radius, so I don't need to say magnitude, is equal to the square root of 2 squared plus -4 squared, which is equal to the square root of 20. Again, you can simplify it. I'm not going to make you do it. All right, so this is my radius. That's the easy part. Next part does require a calculator. All right, so it's inverse tangent of y over x, so -4 over 2. Again, I asked myself, hey, self, was x positive or negative? Oh, x was positive. So because x was positive, whatever answer I get here, that is going to be my answer. So, again, boop, 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 into the calculator. I get a -63.43 degrees. All right, so let's see what's next. As this one says, hey, find 2 pairs of polar coordinates for the point -2, -4. Notice this time the x coordinate is negative, and we're going to have to do something a little bit different. Okay, now the actual, the quote-unquote magnitude or the r value, the radius for this, is going to be the exact same thing, because a -2 squared plus a -4 squared is still going to equal to the square root of 20. But where this is different is in the theta. And so your theta is going to equal same thing here, inverse tangent of -4 this time over -2. And when I put that in my calculator, it comes out and says 63.43 degrees. And this is why it's important. Is why? Because look, if I graph -2, -4, -2, -4 is right here. Boom. Now if I come over here and graph on here the polar part, so here's my pole, right? 63.43 degrees, so it's right this, square root of 20 up here. There's that right there. They're not in the same place. However, if I were to go ahead and do what they asked me to do, which is, hey, when I recognize that x is negative, I just simply add 180 degrees. And when I do that, I get 243.43. And now that's right, because now when I do the 243 degrees, here I am over here, look, they match. This matches up with that. There's my points. Okay? So remember that. When x is negative, add the 180 degrees. So this one is your turn. I come over here. And we take a look at this robotics one. It says, refer to the beginning of this lesson. Suppose that the robot is facing due east and it sensibly detects an object at 3,280 degrees. What are the rectangular coordinates that the robot will need to calculate? Ooh. Okay, so I want to put this into rectangular form. So I'm going to hit pause. I want you guys to write out, how do I write this in rectangular form? Okay. Here we go. I'm going to pause it right now. Bada bing. There it is. There are your answers. Now, again, while we're sitting here talking, my expectation is that you guys are able to get, let's see here, this right here. You guys are not, I'm expecting right now, to get this unless you happen to have a calculator handy at the same time. Okay. So let's take a look at what's next. Another one. Get you guys' practice going. Okay. Again, this is another robotics one. Refer to the beginning. Okay. If a previously detected object has a rectangular coordinate of 4,9, what is the distance and angle measure? So again, when they ask for distance and angle measure of the object relative to the front of the robot, Okay, they're again asking for at this point, what is the polar coordinates? So please take a moment, find out the polar coordinates for this as best you can without using a calculator. I'm going to go ahead and hit pause right about now. And bam, there it is. And again, what my expectations are is that you would get this value here without a calculator, and you're able to get this right here. And again, notice I did not have to add 180 degrees. Why? Because this value is positive. If it was negative, I would add 180 degrees. All right. So so we've done a lot of converting of coordinates. You know, give me a polar coordinate, I'll give you a rectangular coordinate. Give me a rectangular, give you polar. Okay? So that's what we've done. But now what about actual equations? Can we do the same thing for equations? And the correct answer is yes, but it's not as fun. Okay. So here they ask you, this question is asking you to identify the graph, then write the equation in polar form. Support your answer by graphing the polar equation. So what are we going to use? I want to be able to make this into a polar graph. Well, starters here, this tells me here, look, when I take a look at this, this is a circle. You should be able to get that much. And my center happens to be at 2, 0, negative 2, 0, and it has a radius of 2. So when I graph this little thing, negative 2, 0, there's my center, and it's a radius at 2. There's my circle. And I want to be able to write an equation in polar form, so in other words, r equals. Well, how do I do this? Well, the way that I do this is I go back to, well, what does x and y really equal? So if I want to go from rectangular to polar, I got to go back to that whole thing. The x and y is r cosine theta, comma, r sine theta. That's my x, that's my y. So I replace. What does that mean? That means that wherever I see an x, I put r cosine theta. Whoops. Plus the 2 squared plus a y squared. Oh, that's just r sine theta squared is equal to 4. Now I go ahead and I'm going to expand this. So I got to use FOIL here. When I use FOIL, I get r squared cosine squared theta plus 4 r cosine theta plus a 4. So I FOILed this part first, plus, well then I just square this, that's r squared sine squared theta is equal to 4. You're going, wow, that really didn't help a whole lot. Well, yes and no. So a couple of things I can see right offhand here is if I subtract a 4 from each side, subtract a 4 from here, I subtract a 4 from here, I get 0 over here. And then I'm going to move these together and factor out the r squared because the r squared is the same. So when I do that, I now have an r squared times a cosine squared theta plus a sine squared theta. And then I put over here plus a 4r cosine theta. Remember I subtracted the 4 from each side, and so now I have equals 0. Okay, and looky, looky, looky. See here? Look, cosine squared plus sine squared. Well, that's just really a 1. Well, that was handy. And you know what? I'm going to put all of this on this side as well. So now what I end up getting is r squared is equal to a negative 4 r cosine theta. Right? And then what I do is I go, I can go ahead and, yep. And then what do? I can divide by r. Yeah, I can do that. Yeah, I think so, right? Divide both sides by r. Now I got r is equal to a -4 cosine theta. Now graph it on your graphing calculator, if you have one, anything. And there it is. There's my polar equation. And you're going, but mister, there's no way I would have, thought of it. Well, it's going to take some time. But the big thing here is when you want to go from rectangular to polar on the equation side is to remember this, and that you know that your final answer needs to be r equals. And you can kind of work your way towards that. The big one was this one this piece right here. All right? So what about going the other way? And they say, give me this equation, theta equals pi over 4 in rectangular form. Oof. Wow. That's what do I do with that? How am I supposed to get x and y from there? Well, the big things to remember, here are the big things to remember, and it's not always here, is that usually there's a cosine or a sine in a polar equation. So things you need to remember is that cosine of theta is equal to, let's see here, the x over the radius, x over r, and sine of theta is equal to y over r. And generally you would be placing those into your equation. Okay, so if you saw a cosine, you put x over r. If you saw a sine, you put y over r. So that's key to know. This is kind of a unique situation though. This doesn't have sine or cosine. There's no r, it's just theta. So this one involves a little trick. The trick is if I take the tangent of both sides. Well, if I take the tangent of both sides, and again, that's the trick, that's what I know and you don't, and I'm trying to teach you. Well, what happens? The tangent of pi over 4, if you put that in your calculator, is 1. And now I'm just left with tangent of theta. So the last relationship that we need to know about, right, is tangent of theta is equal to y over x. Okay, well, now I can take that piece of information and come over here. Now I have y over x is equal to 1. Multiply both sides by x. I get y is equal to x. And it's a line. Wow. You're going, ooh, way to go, mister. You got y to equal x. It's not, I didn't tell you it was going to be, impressive. But these are the things you need to know. So this is important for you to know, and to know that your goal when you're going from polar to coordinates, the rectangular, is that you need to get something that is y equals. So this is important. You might want to write that down someplace. So what do I got to do? Last part. I think that was it. Yep, that was it. All right. It was good talking to you. See you guys tomorrow. Bye.